Today we're going to start working lesson 10.2 on measuring angles and arcs related to circles. So we're going to find measures of angles and arcs using the properties of circles. We're going to work to find arc length, and we're going to work on converting between degrees and radians. That second concept is going to be more geared for tomorrow rather than what we're going to work on right now. Okay, so let's talk about measuring angles and arcs and how they relate to circles. Okay, so it all begins with this concept of a central angle of a circle. Okay, a central angle is just an angle, but it's special to a circle in that the vertex of the angle is the center point of the circle. And then that makes the sides of this angle radii of the circle. So it looks something like this. Okay, so here in this example, in this circle B, again, we name the circle by the center point, angle ABC is a central angle. BA, BC are radii of the circle because they have endpoints at the center and on the circle. B is the center and it's also the vertex of my angle. So that's a central angle. Okay. The topic of, or the concept of a degree, basically what was determined is that 1/360th of a circular rotation around a point is considered a degree. So if you think of the hands on a clock or whatnot, all right, so let's say BA is what we're looking at. If I move this 1/360th of a movement to the right along the circle, that's a degree. So we understand that if we come all the way around back to where we began, we've traveled 360 degrees. So that's how we define degree. Okay. We have a couple of concepts that we should be familiar with angles that apply to central angles because they're just angles anyway. But we want to make sure that we point all this out. And this just says that the sum of the measures of central angles of a circle with no interior points in common is going to be 360 degrees. All right, so what we're saying is if we take this circle, for example, that I have here, it's made up of three central angles. So we got central angle 1, central angle 2, and central angle 3. These central angles together represent the entire circle, the entire distance around the circle. So these three central angles have to add up to 360 degrees because they cover the entire distance around the circle. So the central angles in a circle can add up to 360 degrees, will add up to 360 degrees. Okay, hopefully that makes sense to you there. Okay, talking a little bit now about arcs. So what is an arc? So essentially an arc is just going to be a part of the circle that's defined by two endpoints. So if you come over here and look at circle Q, okay, I have a diameter drawing of RT, right? A diameter is a chord because it has its endpoints on the circle, and it also passes through the center. So RT is a diameter, QP is shown to be a radius. Okay, so we have several different arcs that are created. For example, arc RP would be this distance, the distance from endpoint R to point P. That part of the circle is called arc RP. We could look at arc PT. Between any 2 points, we can look at that piece of the circle and call it an arc. Okay, we could look at arc, and we name these arcs different ways, and we'll get into that. But basically, an arc is a part of the circle, and it's created by points that are on the circle, and we look between those 2 points on that path of the circle. Okay. So anytime you have a central angle in a circle, so for example, if I look at angle PQT, this central angle, it really divides the circle into two different arcs. Okay, you got arc PT, which is here, this smaller arc, and then you have the arc that would go from P through R and S all the way around to T. So even though that's what we would call a major arc, we'll get to that in a second. The central angle has still divided the circle into two different arcs. Okay, so one type of arc we have is what's called a minor arc, and a minor arc has a measure that's less than 180 degrees. We know the full distance around the circle is 360, so we know half the distance around is 180. So any arc that's less than halfway around the circle is going to be a minor arc. Okay. What we also understand is that these angles are related to the arcs they intersect. All right, so the angle created by PQT, this angle, whatever that angle measure is, we assign this arc that same measure. Okay, so the measure of arc, let's look up here at PR. So PR is a minor arc. It's less than halfway around the circle, right? So PR is a minor arc. Whatever the measure of angle PQR is, whatever this central angle is, let's say it's 120 degrees. If PQR is 120 degrees, then arc PR we will say is a 120 degree arc. So a central angle and the arc it intercepts are going to have the same measure. Okay. PT is another minor arc, and it's related to a central angle PQT. Okay, whatever this angle measure is, we assign this arc the same measure. So the central angle and the arc are related in measure. Okay, a major arc is an arc that's greater than 180 degrees. In other words, it goes more than halfway around the circle. Okay, so if you look at a major arc, an example would be, and we usually use 3 letters. Notice we use 2 letters up here to describe a minor arc. We go right from point P to point T, right from point P to point R. When we do a major arc, we usually use 3 letters. So for example, if I want to look at at this arc that starts at P and ends at S, I would have to name it PRS. The third point you have to pass through before you get to your last point when we name it. So let's look at this. Okay, let's look at RSP. So RSP is this arc. Okay, now again, that third letter, which is our middle letter, we have to pass through it before we can get to our last point. So I couldn't go this way and call that RP because I didn't include S. To get S in there, I got to go R along the circle through S and end at P. Okay. Now, the interesting thing is that if I want to find the measure of this arc, RSP, what I can do is I can take the minor arc created by the endpoints R and P, subtract it from 360, and what's left has to be the major arc. We will have different ways of finding these arc measures. Okay, I think if you think about that a little bit, that'll make sense to you though. Okay, continuing on, we talk about semicircles. These are exactly 180 degrees, right on the nose. The endpoints of a semicircle are on a diameter. So in this case, like if I look at TSR, this arc, it is a semicircle because TR are the endpoints of a diameter. So that makes the arc here, that makes that arc a semicircle. Okay, so the measure of angle, the measure of arc RST is going to be 180 degrees. Okay, exactly. Congruent arcs, okay, arcs that are congruent mean they're exactly the same. It means they're carbon copies of each other. So if we're going to talk about congruent arcs, they either got to come from the same circle or 2 circles that I know are congruent. And if we get arcs in the same circle or congruent circles that have the same measure, then they are going to be congruent. I mean, congruent again means they are identical to each other. We can lay one on top of the other, it'd be a perfect match. Okay, so that's a little bit about arcs. Okay, a couple of ideas here to add to it. This first one is Theorem 10.2. What this says is that if you're in the same circle or in congruent circles, 2 minor arcs are congruent if and only if their central angles are congruent. Now, this kind of stands to reason, kind of common sense. So what we're saying here is, let's take a look at this circle here. We got circle L, and we have 2 labeled central angles. We got this angle 1 that's labeled and angle 2 that's labeled. Angle 1, central angle, relates to arc FG. Angle 2 as a central angle relates to JH. So what this theorem says is, if I know angle 1 and angle 2 are congruent, then arc FG and arc JH have to be congruent. So if 1 and 2 have the same measure, FG and JH have to have the same measure. Common sense, right? We just said that a arc and its central angle are the same. So this is just making that statement. And then the converse of this, because we used if and only if, biconditional, that means the converse is true. So let's say we knew that this arc FG and this arc JH were the same. Well, then their two angles would have to be the same. So 1 and 2 would have to be congruent. Kind of common sense, but they just like to give you theorems like this to get you thinking about other ways we can apply it. Okay. Another concept we need to touch on is adjacent arcs. Now, if you remember, we've seen this term adjacent before because we dealt with adjacent angles. Adjacent angles were two angles that were kind of side by side. They shared a common side. Okay. Well, an adjacent arc is going to share a common point. So if we look at circle M here, if I look at arc HJ and then arc JK, those two would be adjacent arcs. And the reason is they meet at point J. Okay, they bump right up next to each other. There's no separation here. So what happens is HJ and JK are what we call adjacent arcs. And when you have adjacent arcs, we can add these measures together if we need to find the length of, let's say, HK. And that's what this last postulate says. It says that the measure of an arc formed by two adjacent arcs is the sum of the measures of the arcs. Well, again, it's kind of common sense stuff, but we like to point it out. So let's say you're given this circle, and we have these points along the circle. Okay, what we know has to be true, just like it did kind of with angles, is that if I take the measure of arc XY and add the measure of arc YZ, that's got to equal the measure of arc XZ. So these two arcs added together equal the combination of them. Okay, we've seen things like that with segments. We've seen things like that with angles. Now we're using that same concept with arcs. Okay? All right, let's look at some question types you're going to get tonight. All right, find the measures of the central angles. Okay, so we're supposed to find X in this case. So we're supposed to find the measure of arc, of central angle DAE. Okay, well, what we know is this circle has been cut into four different central angles, 85, 40, this is 90, and this is X. We know that these four have to add up to 360. So we know these central angles, EAB, BAC, CAD, DAE, these four have to add up to 360. So it becomes a simple little equation to solve. Plug in what we know. We know that EAB, we knew that was 90. BAC, we knew was 40. CAD, we knew was 85. And DAE, which we're looking for, is X. So we plug our numbers in, simplify, solve, and X is 145. So this angle, DAE, is 145 degrees. You also now know that arc DE would be called a 145 degree arc. Okay, let's look at this one. This one now, instead of the circle being divided into four different central angles, now it's divided only into three, but the same concept holds true. These three angles encompass the whole circle, so they got to equal 360. So again, simple solving process. And in this case, this would be a 50 degree central angle. This arc would then be a 50 degree arc. Okay, pretty simple to work with these. And we're going to have other concepts that apply here with central angles and with these angles and segments that are intersecting. There's other things we'll do. Okay, but that's our start there. Okay, now looking at arcs, being able to classify arcs and being able to find arc measures. So you're given a question like this. So we got circle R. And notice up here they're telling us that PM is a diameter. That's important. We have to know that this is a straight line. By knowing that this is a diameter, okay, we know that PNM has to equal 180, and we know PQM has to equal 180. And that we need to know to be able to solve this problem. What I do first in these questions is I fill in all the angles. Okay, so I know PRN is 90 degrees. I'm going to do that first. Now, because PNM is a semicircle that equals 180, that means NRM, that's got to be 90 degrees too. And then to find MRQ, I know that these two angles, PRQ and QRM, they got to equal 180. So if I do 180 minus 115, I know this angle, QRM has got to be 65 degrees. Okay, so now I'm armed with everything I need. Now I can go look at my different arcs and use these angles to determine what the measures is. So the first one is MQ. So MQ, again, is this direct shot. You go right from one point to the next. So MQ is going to be a minor arc, and the central angle is the same measure as the arc. So MQ is a minor arc, and it would be 65 degrees. Okay. MN is also a minor arc. It's the distance from M to N here. And again, the central angle and the arc are the same. So this is a minor arc, MN, and its angle measures 90 degrees. Okay, MNP. So we got to start at M, go through N on our way to P. So MNP. MNP, well, we knew that this was a semicircle. So it's a semicircle, and every semicircle is exactly 180 degrees. Okay, MNQ. Now I got to go from M, start at M, go through N on my way to Q. So I'm coming all the way around. Okay, so the sum of these central angles is the same idea as the sum of the arcs. So I know to get M and Q, I'm going to add up 90, 90, 115. Or I could have done 360 minus 65. The answers are the same. It's a major arc because it goes more than halfway around, and it's 295 degrees. Okay, QMN. So Q through M to N. All right, that is less than half a circle. So that's a minor arc. And QMN is going to be the sum of 65 and 90. So that's a minor arc. It's 155 degrees. And then PQN, PQ to N. So start at P, go through Q, end at N. So that is more than halfway around. That's a major arc, and that's going to be 115 plus 65 plus 90, or 360 minus 90. Either way, you're going to get 270. Okay, so that's a little bit about naming arcs, identifying arcs, and giving their measures. So that's where we're going to start. I'm going to have you guys work on some basic questions that involve central angles, looking at the arc measures and so forth, some real basic stuff to start off with, and we'll pick up and do more of this tomorrow.